Hey guys, today I'll be showing you a thermal analysis using WELSIM. So let's start. I double click this icon on my desktop. So let's check the version. Click help. This is about WELSIM 1.4. The version I'm using 1.4. The building date November 14, 2017. The version number is 1880. I'm using Windows 10 operating system. So if you have Windows 7 or 8.1, it can be used as well. Let's click this button on the toolbar called create a new simulation project. Let's click it. Oh, because I'm using the evaluation version, so just click the evaluation. You can proceed. If your WELSIM software has been activated, you won't see this pop-up window. Now we have this project. I click this project node, and we see a bunch of options in this property window. The first one is numerical method, definitely find an element method, which is read-only, and the 3D analysis. In physics types, if we click this drop-down list, we see several options: structure, thermal, electromagnetic, fluids. So today we're going to use the thermal, and we do the static analysis. It's basically steady-state thermal analysis. Okay, now let's bring a geometry. I'm going to use the edge section for this time. This is also my favorite geometry. I see this size of the geometry kind of big. It's almost 100. If it is MKS unit system, it's kind of very huge. So I'm going to scale this geometry. Let's click this geometry object, and we see there's several properties. Scale changes from 1 to 0.001, which means we shrink this 1000 times. Okay, and double check the size. So if the MKS units, it's about 0.1 meter. Okay, the material this time we'll keep using this default structure steel, which is already defined on this tree list. So for the thermal analysis, double click this structure steel, and we see the details about this material. We see the density, which is used in the thermal analysis, specific heat, and the thermal conductivity. Click the OK button, go back to the main window. Okay, let's mesh, see what's going on. This mesh is kind of too coarse, so change the maximum size of an element to 0.01. Let's remesh. Okay, so this time the mesh is not perfect, but it's fine. So considering we want a fast solve at this moment, let's just use it. I should be able to get the correct results. But definitely you can reduce this number, then you can get a better mesh. This is the high order elements. If we check the node and the elements, we can see. So the nodes about almost 3,000 nodes and 1,384 elements, which is 10 elements. Impose some thermal boundary conditions. We have two temperature objects added. The first temperature we're going to impose on the left side. Okay. Then we're going to give it 300 degree. Okay. The second temperature boundary imposed on the right side. I'll give it to 22. It's basically the room temperature. Okay. Now we have two boundary conditions, one on left and another one on right. Okay. So since this is a static analysis, we can just solve it now. We can click this sliding symbol on the toolbar and get it solved, or we can right-click on the answer. We see this compute option here. It's the same thing. We can just run it and see. Oh, because our project is never saved, so if it's not saved, the project will ask you to save to some place. Let's set 008. Okay, it's solved very fast. It only takes about 0.11 second. So then we add a temperature object here. Okay, double click and see this result already showing on the screen. It's pretty nice. In the left side, all red, it's about 300. The right side is 22. Very rational, very quick. If you don't like this color type pattern, you can change to the smooth pattern. It's better. And if you don't like a rainbow, like the black and white, oh, looks good. Let's go back to the default setting. Okay, so this is basically the static thermal analysis, very quick and easy. If you have any question or suggestion or comments, please let us know. And you can download the WELSIM directly from our website, welsim.com. Thanks for watching. Bye.